All right, I'm going to start with a simple one. So when we talk about anion, there are two type of anion. The first one is called monoatomic anion. The second one is called poly, right? Polyatomic anion. What does it mean? Atomic anion. Monoatomic anion means you have only one element as an anion. If you just have one element as an anion, that is called monoatomic anion. When you have more than one, right? More than one element as an anion, then you are calling that as a polyatomic anion. Is that clear? Do you understand the terms? I'm going to explain you the example, but do you understand the term?
Yes, Professor.
Right? Mono and poly. Poly means more than one. Now, what are the example of monoatomic anion? So like NaCl, in which you have this Cl, right? Which is anion. And you just have one element, which is Cl itself. This is called monoatomic anion. If you have, let's see what I can, the other example I can give is MgO, right? In this case, Mg is a cation, oxygen is anion. What do we have as anion? Oxygen itself, one element, right? Other example could be, let's say Aln, right? Aluminium is a cation. Nitrogen is an anion. What do we have as an anion? Just one element itself. Do you follow me what I'm saying?
Yeah.
All right. So if you have just one element, it could have more than one atom, right? It could have, let me just give you another
Like
example like this.
zinc chloride.
Al2O3, right? For example, zinc would be a bit more complicated, so I'm not going to talk about that, but let's talk about this, right? In this case, aluminum, of course, we know is a positive ion, oxygen is a negative ion, right?
Yeah.
All right, so this is going to be anion. Even if we have more than one atom, which you see three here, we can still say there is just one element, right? Oxygen is the only one element you have as an anion. In that case, you can call this as differently. All right, so in this example, you still can call this as a monoatomic anion. Nitrogen itself, one element, anion, right? Monoatomic. Oxygen itself, chlorine itself, it is monoatomic anion. The other example of like the example of polyatomic anion would be like this. Uh, let's see if you, okay. So let's start with a simple one. NaOH. In this example, Na is a cation and OH together is anion. All right, oxygen and hydrogen together is called anion. All right, another example could be like CuSO4, in which copper is a cation and SO4 together is anion. All right, I'm going to explain you how to remember this all anion, but just try to focus on how to differentiate this monoatomic and polyatomic, right? At the moment, like let's say NaNO3. In this case, Na is a cation, NO3 is anion. So do you see, in all this example, you have more than one element which is acting as an anion, while in the example on the left side, you have only one element acting as an anion. Do you see the difference?
Yes. Yeah.
Everyone, do you see
Yes,
the difference?
Professor.
Yes.
Yes, Professor.
All right. So this is called monoatomic. And if it's monoatomic, how are we going to name it? The way we learned, we are always going to use IDE as suffix, right? So for, let's start with the nitrogen, carbon nitrogen. Nitrogen, as we know from the last time, nitride, right? We learned this in the molecular compound as well. If it's oxygen, it will be oxide. If it's phosphorus, phosphide. If it's sulfur, sulfide. You already know fluorine would be fluoride. Chlorine would be chloride. Bromine would be bromide. I just don't have space. I'm going to write it here. Iodine would be iodide. Do you follow me?
Yes, Professor.
All right. So this is not hard, right? This is easy. All you have to do is replace the name of the like replace the last few letters of the name of an element with IDE. There are few that you may have to remember, but I think you will get it with your practice, right? As you practice more and more, it will come naturally. Nitrogen would be nitride, right? And nitrogen would be nitride. Oxygen, oxide. Phosphorus, phosphide. Sulfur, sulfide. All right, do you see that? Everybody, you good?
Yes. Yeah.
Okay, so as long as you know if there is only one element as an anion, this is how you can name it, right? We are going to discuss more of this in detail, but before we talk about that, I think we should practice a couple of more example in which you are going to use these names. All right, so at least take the picture of this before I erase this. All right, if you remember this, is wonderful. If you don't yet, it's completely fine. Just go over this again and again, maybe like 3-4 times, and you will get it. All right, it's not hard. So I'm gonna give you like 10 more seconds to take the picture if you haven't done it yet, and then I'm gonna give you a few example in which you have to come up with the names. All right. Okay, can I erase it now?
Yes.
Yeah.
Yes, Professor.
Okay, thank you so much. All right, so let me just give you a few example in which I want you to write down the name. So Mg, okay, let me start with this one. All right, E F G 2 L 2O3. Just give you one here. I think we talked about it. Okay. So instead of asking you question, I'm just going to give you the answer because I know you need to understand this rather than thinking about this. All right, but please stay focused. All right, try to understand as much as you can. Remember, you have like entire semester to learn this. This is just an advanced learning, right, that you're doing right now. So in this case, what you need to do, you need to identify whether it is a ionic compound or molecular compound. Looking at this, you already know Na, it is a metal, so it is a metal. This is non-metal, it means it is an ionic compound. Everybody agree?
Yes. Yes, Professor.
Right, Na is a metal, non-metal. Of course, when it is a metal, how you going to name it? Can anybody answer that? Na is an
Name
metal.
element.
Of course, right? Just name it as an element. So this is going to be sodium. F is an anion. How are you going to name the anion?
Chlorine.
Fluoride. So the difference between the molecular compound and the ionic compound is here. No matter what numbers you have as a subscript, you do not need to write that down in the names. In the molecular compound, depending on the subscript, we use prefixes, right? If there are two, then we say di. If there are three, we call it tri. If there are four, we call it tetra. Remember, that rule does not apply at all if it's an ionic compound, right? The first example name would be sodium fluoride. Second example, we just need to see Mg, it is a metal element. Cl is a non-metal element. Mg is magnesium, right? Magnesium. And Cl, what is Cl? It
Right.
is chloride. All right, in here you remember, even though we had two atoms of chlorine, but still we just have one element as an anion, chlorine itself, right? We do not have any other element together with chlorine as an anion. So we remember it is also called monoatomic, right? And if it's monoatomic, we are going to use IDE as suffix. The third example, right? Al, we know aluminium
I have a
is,
question.
yes, go ahead.
Sorry, for the last one, why is it not magnesium dichloride? Can you remind me?
That's what I just explained you, right? For ionic compound, because this is ionic compound, right? In ionic compound, we do not write the prefix like di, tri, tetra, penta. We do not write that. That rule only apply to the molecular compound. When you write the ionic compound, you do not mention how many of the oxygen or aluminum or chlorine you have in the formula. Do you understand?
Yeah, that makes sense.
Yeah. And there is a reason behind it, which I'm going to explain you in a few minutes. Okay. So the name of the third compound, right? In the third compound, what we need to identify. So every time when you have a chemical formula, first question you should ask is whether it is an ionic compound or molecular compound. By looking at the formula, you know aluminum is Al, is a metal, oxygen is non-metal, so this is going to be considered as ionic compound. If it is an ionic compound, the first element, we like for the first element, we're just going to name it as an element, right? For the cation, so this is going to be aluminum. Al is aluminum. Oxygen, it is an ion which is by itself, it does not have any other elements, so we are going to call it as a IDE, oxide. Aluminum oxide is the name. Again, as I told you, for ionic compound, we do not write prefix like di, tetra, penta. Do not write prefix neither for cation, neither for anion, right? Do you understand this now? Is it clear?
Yes, Professor.
Yeah. Okay. And the last one, Cu, right? In this case, we know Cu is a cation, oxygen is anion, oxygen is by itself, right? So of course, we are going to use IDE as suffix, so oxide. Copper, we're just going to name it as an element, copper. But in this example, you have to look at it where copper is located. If you check the periodic table, you will see copper is located in a transition element. It means it can have more than one charge. So actually, I'm going to explain you this later, but copper can have plus one charge, or it can also has plus two charge. In this example, it is carrying plus two charge. So we have to write a parenthesis and we're going to write number two. So this is how you should write. In the in a couple of minutes, I'm going to explain you why did we write two or three or four, right? Whatever it is, I'm going to explain you. But let me know, do you understand these names? Do you understand what rules we following?
Yes.
Yes.
Professor, I got a question.
Sure, go ahead.
Uh, why didn't you put the Roman numeral 2
for aluminum?
Again, same thing. Aluminum cannot carry more than one charge. Aluminum is always plus 3. All right. So if any element cannot carry more than one charge, we do not need to specify. For sodium, I did not do that, right? Magnesium, I did not do that. Aluminum, I did not do that. Aluminum is not a transition element. If you look at the periodic table, you will see that it does not follow in the small section of the periodic table. It is not a transition element.
One question.
Go ahead.
So
Sure. Just 1 minute before I answer your question. Does somebody who asked me that question earlier? Do you understand that? Why I did not write a parenthesis for aluminum?
Yes. And so then if this is an example on the test, we just don't look at the 2. Just forget about the 2.
Oh,
Or
yes.
forget about whatever charge that they put on the element.
Yes, that's right.
Okay. Thank you.
Okay, good. Yeah. Next question. Go ahead.
Oh, actually, it's okay. I found it.
Sure.
Yeah.
Okay, no problem. All right. So again, for ionic compound, remember that if it's an ionic compound, the metal is always going to form a cation. Non-metal is always going to form anion. For cation, you always name as an element, right? There is only one additional point in which if that element belongs to the transition element section of the periodic table, you also write parenthesis and Roman numeral to explain what charge it carries. If it does not, if the element does not follow in that small section of the periodic table, right, then you do not have to, you never ever write a parenthesis and Roman numeral. You only write parenthesis and Roman numeral for element which actually can carry two different charges. It could be +2 or +3, it could be +1 or +2. Then you have to say what charge that element is carrying in the given formula. Otherwise, you don't have to specify. All right. Again, everything in group number 1A, 2A, and 3A, you never ever has to write a Roman numeral. No Roman numeral. Okay. Will you remember this?
Yes,
Yes, Professor.
Excellent.
Yes.
Excellent. All right. So now let's just go back and see how we can write a chemical formula and how do we identify what charges are there. All right. So let's say if I'm going to ask you a simple question, right? I give you so many examples, so I think it will be hard for me to come up with something else. Calcium and oxygen. All right. These are the two elements. Let me ask you, what is calcium? It is a metal or non-metal?
Non-metal.
Metal.
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 Non-metal. Wait.
Non-metal.
Non-metal.
Metal.
Ca.
Ca, right?
Metal.
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 Oh, shit.
Yeah,
bad.
that is completely fine, right? You just need to be more familiar with the periodic table. So that is completely fine. But as long as you see it now, it's important, right? So yes, this is metal. Oxygen, of course, we discussed it so many times,
Non-metal.
is non-metal, right? When metal and non-metal comes together, the type of compound it's going to make is ionic compound, right? So
Yes.
if, what I'm trying to say here is like, I'm asking you to come up with the chemical formula for the compound that contain calcium and oxygen. All right, because you see in the previous formula we see like different subscript, right? 2, 3, and something like that. How can you come up with those subscript? That's the point. All right, so in this case, yes, it is forming ionic compound. Ionic compound means what? One is going to be positive ion, the other one is going to be negative ion. Yeah, in this case, of course, metal is going to be positive ion, so calcium is going to be positive ion and oxygen is going to be negative ion. Now, let me ask you, what charge do you think calcium is going to carry? If it's positive, we know that. What positive charge calcium can carry?
Two.
Anybody?
2.
2.
Excellent. Always 2. Why? Because it is present in group number 2A if any element is present in group number 2A, it is always going to carry +2 charge. That's right. For oxygen, what do you think oxygen is going to carry? What charge?
6.
-2.
Everyone?
6.
Yeah, -2.
Negative 2.
-2.
Yes. For the charge, this is how it works. It's not just the group number. This is how you have to remember. 7A minus 1, 6A minus 2, 5A minus 3. All right. So oxygen is here, so it is going to carry -2 charge. All right. Now, when you have to write a chemical formula, all you have to do is kind of cross multiply this charge, right? Okay, I shouldn't draw this arrow here. My bad. Cross multiply the charge as a subscript. So the charge from the we have on anion that goes as a subscript to cation. So it should be Ca2O2. Do you see what I did?
Yes, Professor.
All
Yes.
right. And in this case, right, because the subscript is this kind of, and now we just need to simplify the subscript, right? Because both of them are 2, you have a common factor, which is 2, you can divide that. So 2, 2, so it would be CaO, there is 1 and 1. So CaO, or you can just simplify this, right? Ca2O2, what does it mean? You can just cancel this 2, 2 out. And the name, or I would say the chemical formula of this compound is going to be CaO. Okay. Another way to explain you this is, you can also do this, Ca plus 2, O minus 2. When you're going to write any of the 2 ion together as a chemical formula, right? This is the chemical formula. The intention to get to this point is to have a total charge which is equal to 0. What is the charge here? What do you see the charge? +2. What do you see as a charge? -2. So +2 minus 2 would be 0, right?
Yeah.
Right. So
Yes.
total charge is 0. When you end up as a total charge 0, that is the right number of atom for cation and anion. You can put them together, otherwise you cannot. So in this case, you just need 1 calcium and 1 oxygen to get to the total of 0. So you can say CaO. Do you follow me? Because both of them carry same charge, +2 -2, the positive charge and the negative charge cancels out, so you can put them together. Same way for NaCl, Na carry plus charge, Cl carry minus charge, total would be what? +1 -1 would be 0. If the total of the charge is 0, then you can simply put these 2 elements together as a chemical formula, NaCl. Now let me just give you another example to explain you why this, how this works, right? If it's MgO, no, not Mg. Let me just give you something else. Na, should be the easy one. Calcium. Yes, let's say CaCl. All right. Everybody can see this, right?
Yes.
All right.
Yes, Professor, of course. Yeah,
Okay,
thank you.
great. All right. For calcium, right? We know this is calcium is going to be metal. Cl is non-metal, right? When metal non-metal comes together, it form ionic compound. For ionic compound, one of these is going to be acting as a cation. So of course, calcium is going to be cation. Cl is going to be anion. So let's find out what charge calcium can carry. We already know from the last time, right? Calcium is in group 2A, always going to be +2, right? Cl, what charge Cl is going to carry then?
-1.
-1. Why? Because it is present in group number 7, right? In this case, what is the point? If you want this to put together, these 2 elements, the total charge has to be 0. Do you think the total of this is 0 right now? +2 -1. Is
No.
it 0?
No.
It's 1.
No.
No.
1.
It is not 0, it's 1,
One.
right? If it does not get to 0, it means you cannot write a chemical formula like this. CaCl, you cannot write that because this is incorrect. Why? Because the total of this charge is not 0 yet. In order to make this total charge as 0, what you can do, you can just simply cross multiply these charges, right? That's what I just said here. So what you should end up with, Ca, there is 1, so you don't have to write 1, and Cl is going to be what? 2. So CaCl2 is the correct chemical formula. CaCl is incorrect chemical formula. Do you see that? This is the simple way to do it. Do you understand this?
Yes.
And,
Yeah.
do all ionic bond has to equal at the end equal to 0, like all of them?
Yes. For ionic compound, if you want to write down a chemical formula for the ionic compound, the total charge, the cation and negative, like anion, has to be the same. Right? I understand you still have more question. I'm just going to explain you, I think, here. All right. So it will be more clear to you. So CaCl. So what does it work? How does it work? Ca plus 2 and Cl minus. If the total of this charge is not 0, you cannot write a chemical formula. It means that whatever chemical formula you're going to write, in which the total is not 0, then it is incorrect. So what you have to do in this case, the total is, here is plus 2 minus 1. Total is 1 right now, right? If you want to make this charge equal, what you can do, you can have another Cl minus, right? Now it is plus 2 minus 1 minus 1. It means 2 plus 2 minus 2, right? Do you follow me?
Yes.
Yes.
All right. Okay, I did not get the answer from everybody. Do you guys understand this?
Yes. Yes, we do.
Right?
Yes.
In order
Yes,
to make
Professor.
the total charge 0, we need one more Cl minus. Simple, right? Because we need one more Cl minus to make the total charge of 0, the correct chemical formula is going to look like Ca, we just need one of it, and Cl, we needed 2 of this to make the total of 0. Do you follow me?
Yes.
Yes.
So either you can just do the zigzag cross multiplication in order to get a correct subscript, or you can just simply try this method out and find out yourself. All right, let me erase this and give you more example. Right, Al and O. All right, I think I'm gonna let you do this after a few minutes. Let me just give you another example. Na and O. All right, in this case we know Na is a metal, it is going to form a positive charge. So let me ask you, what charge Na is going to carry?
+1.
Everybody, +1?
Yes, +1.
Right, and oxygen, we
Yeah.
already discussed so many times, it will be
-2.
Negative 2. Yeah.
Yeah. So in this case, by using the first method, right, the first method was cross multiplication. So what you can do,
Yeah.
you can simply cross
Na2O.
multiply. Yep. So it should be what? Na2
2O.
and O. Yes, this is the correct chemical formula. If you write an answer as NaO, it is going to be incorrect. Why? Because the total of this charge is not 0. So this is incorrect formula. All right, this is one method. The second method is what? We just need to find out the total has to be 0. In this case, total is not 0 yet, right? I would say the positive charge and the negative charge is not same yet. To make the same positive and same negative charge, what you have to do, you need to have one more sodium, right? One more Na plus, so that the total positive charge, which is going to be 2 here, will be equal to the total negative charge. You see? All right. And in order to do that, what did you do? You need 1 and 2 of Na and just 1 of the oxygen. So this is how we can come up with.
Professor,
Yes.
So is it basically you like cross multiply the exponent, the numbers, and then they have to be positive? Is that like how you do it?
Yes, you just cross multiply the number. Do not cross multiply the sign, right? Because this is the charge. That's why it's minus and plus. All you need to do is cross multiply this the numbers, and you will get the right chemical formula.
Okay. It always ends up being positive, right? Like I
Oh
see.
yes, yes. The answer has to be like the subscript, the number that we are writing here, that is called subscript, and subscript always has to be positive number. Make sense?
Yes, sir. Thank you.
All right.
Professor, I have a question.
Go ahead.
In regards to the 3A, 4A, 5A. So if 7A is -3, I mean,
Yeah.
7A is -1, right? Or no,
Yes.
-3.
-1.
-1, right? Okay. So then 6A is -2, 5A is -3. Is 4A -4?
No, we do not apply that rule to the 4A. Were you here in a last session?
No, I
No?
had to
Okay.
work. Sorry.
Yeah, I realize. Okay. So anyway, like the recording is already available, so you can definitely check that out. It will kind of answer all your questions. All right. I
Okay,
already
thank
explained it.
you.
All right. No problem.
No problem. Thank you.
Right. So I hope you guys understand this, right? Let me just go back to the first example that I kind of gave it to you. I think, what was that? Was it CNO? What was that? Carbon, like
CACL.
Carbon, I think it was O.
yeah, it was O, right? Yeah, I think was it this. So in this case, right, we did discuss that earlier, but I think now it will be more clear to you. In this case, when you write as a cation, calcium is always going to be form +2, oxygen is always going to be form -2. In this case, you see the total of the positive charge, which is +2, is equal to total of negative charge, which is -2, right? So you can simply put them together, CaO. Do you follow me? That's the
Yes.
reason why you can put them together. Why? Because the total of the positive charge is equal to the total of the negative charge, right? In this case, let's say if you are applying the rule of cross multiplication, right? What do you have to do? You just need to see that you have to simplify this, right? You need to simplify this. Why? Because the subscript has the same common factor, which is going to be 2. When you simplify this, you get CaO. Or you can just simply look at the charge. When the charge of cation and anion is exactly the same, just put them together. Do not think about this. NaF, right? Na is going to be +1 charge, F is going to be -1 charge. The total of this charge is 0, or we can say positive charge is +1, negative charge is -1, exactly the same. Simply put them together, right? Another example would be, let me just give you simple. MgO, right? Mg is always going to be +2. Oxygen is always going to be -2 because the charge is exactly the same, right? Positive charge is equal to the negative charge. That's why you can just simply put them together, MgO. Do you follow me?
Yes, Professor.
All right.
Yes, Professor.
Excellent, excellent. So I'm just gonna give you like maybe like 2 minutes. I think 2 minutes would be too much. So let me just give you 1 minute. All right. Try to do your best to get to the right answer for this example. Aluminum and oxygen.
Professor,
Yes.
for the NaO, why didn't the 2 go past the O? Why did it go to the Na?
Because we are cross multiplying every time. Didn't we do the cross multiplication in all the example? Right. This goes here. That's the only way you can balance it off.
Oh, okay. Thank you.
Right? The positive, like whatever positive charge you have from Na is going to go to the oxygen. Whatever negative charge you have on oxygen is going to go to Na.
Thank you.
Yeah. All right. So anybody?
Yes, it's A203.
Okay. I'm gonna give you like maybe like 30 more seconds. All right. All right. So I hope you guys have tried, and I hope you guys have got the right answer. If you haven't, it's okay. It's all about learning. So we're gonna talk about this right now. Al, as you know, Al is an element, sorry, metal element. Oxygen is a non-metal element, of course, gonna form ionic compound. Al always carry +3 charge. Everybody agree?
Yeah.
Yeah, it's in 3A.
Yep, oxygen is always going to carry -2 charge, right? Very simple. Z cross multiplication, right? Cross multiply to this here, and this goes here. So it should be what? Al2O3. This is the answer. All right. Let me just explain you another method that we already discussed, right? In this case, I had to erase this. So let me just erase this. Al Al we know is +3, O we know is -2. So now in order to make this compound, we know the total charge has to be 0. It means the positive charge has to match with the negative charge. In this case, we have +3 and -2, right? It is not equal. So what we can do, we can have one more oxygen atom, which is going of like one more oxygen anion, which is again going to carry -2 charge. Now we have extra anion, right? Now the total is not 0. Now it's going to be, okay, so in here the total is +1. If we add one more oxygen atom, now it become -1, right? If it become minus, we're trying to balance this off, so we're gonna add one more of Al. If we do that, it will be ending up with
+2.
You follow me, right? You guys are understanding this?
Little
What I'm
confusing.
trying to do is I'm just trying to balance the cation
Confusing.
charge on. Sorry.
This part is a bit confusing.
Yeah.
Okay. So again, as I said, this is just another method to follow, right? You don't have to follow as long as you understand the zigzag and cross multiplication. But this is just an explanation that how actually it can work. All right. What I'm trying to do is I'm trying to put more atoms or like more number of anion and cation until it balance off. All right, that's all I'm doing. So now if I look at the positive charge, what is the positive charge I am going to have? +6, right? +3 would be, total would be +6, right?
Yeah.
On the other side, what is the total negative charge? -2, -2, -2 would be -6. You
So
see, eventually by adding more and more of aluminum and oxygen, at one moment I do get the same positive and same negative charge where the total is going to be 0. All right. And once you figure that out, you know how many aluminum to use, 1 and 2. So there are 2 aluminum, 1, 2, and 3 oxygen.
Oh, so you're finding the least common multiple.
Yes.
Then,
right.
Okay.
All right. If you don't have to follow this method at all, this is just an explanation. All right. As long as you just cross multiply, that always work. And if you in the cross multiplication, let's say if you have a common factor that you can divide your number with and simplify it further on, you must do that. Okay. Any question?
No, sir.
Yeah, go ahead. No question.
Professor, if you already simplified it down with the 6, you already got 6 and 6, and you simplified it, wouldn't it just be ALO? Because you already got 0. Why is it still AL2?
To get 0, How many aluminum did I need? I need 2, right? All right, so I think the way I am writing it doesn't make sense to you, I think. So let's say I have 2 bucket, right? In one bucket I have aluminum plus 3. In here I have oxygen minus 2, right? What I'm asking you to do is I'm asking you to add whatever number of oxygen, and like maybe like I have like 1000 of aluminum plus 3, right? And I have 1000 of O minus 2. Keep adding more of this into the respective bucket until the total charge in this bucket is equal to the total charge in the other bucket. Do you understand?
Yes.
So right now the total charge is not same. This is plus 3, this is minus 2, right? It is not same. Which number is lower? So of course this number is lower. So what we're going to do first, we're going to add one more oxygen, right? So I'm adding one more oxygen. Now it become minus 4, right? And this is plus 3. So 3 is lower than 4. So what I can do, I can add one more Al3 in this bucket. So the total will be what? Plus 6 now. You follow me?
Yes, Professor.
All right.
Yes, Professor.
Now this is minus 4, so it's not same yet. So what I'm going to do, I'm going to add one more oxygen. In this case, when I do it third time, now it become minus 6. So at this point the charge on the both bucket is exactly the same. When it become exactly the same, you need to find out how many of aluminum did you use. You use 2 aluminum, so it should be 2. How many oxygen did you use? You used 3 of them, so it should be 3. All right.
Can you give us another example with different elements, maybe? Just like one more.
Oh, sure.
If
Let's see. Okay. No, and it's not gonna work. Okay, and I gave you so many examples so far, so let me just start something else. Calcium, nitrogen. All right, try this out. If you want, I would always say that cross multiplication method is really simple, saves your time. The second method that I am trying to explain is just for your understanding. All right, if you do the cross multiplication, always work, and it is gonna save a lot of time. All right, so try this out. Calcium and nitrogen, right? We're just going to follow the bucket method first, and then we're gonna follow the simple method, right? As we know, calcium is always going to carry what charge?
2.
2.
Plus 2, right? Nitrogen is always going to carry negative 3 charge.
So it's
All right.
Ca3 and 2.
Sorry?
It's Ca3 and 2.
Exactly, yeah, that's right. All right, just cross multiply this charge, right? And you will see Ca3 and 2. Yes, that is right.
3 calciums to make.
Yep, and if you want to understand in a bucket method, then yes, you have one calcium in this bucket, you have one nitrogen minus 3 in this bucket. The total, this is going to be plus 2, this is minus 3, it's not same. So I'm going to add one more to make it equal, and doing this is not equal yet because this end up with 4, right? So now I have to increase this, so I'm going to add one more of this nitrogen in here. So now the total is minus 6. So again, this is not same. I'm going to add one more calcium plus 2. Now the total is plus 6. Now it is same, right? Plus 6 minus 6 cancels out. It means how many calcium did I need to kind of make this charge equal? I need 3 calcium. How many nitrogen did I need? 2 nitrogen.
So would they, can we use the same, say we have calcium and we have like another one with the same positive charge?
Yep.
Like magnesium?
Yep, we did that, right? Calcium and yeah, with the magnesium, same thing, right?
It'd still be, okay.
Yeah, MgN would be same thing, right? Mg3 and 2. Yeah,
Do we
thing.
have to switch them like different sides, or does that not matter?
What do you mean switch and what size?
For example, like should it be nitrogen? What is it? N2, calcium 3, or calcium 3 and then N2?
Calcium 3 and N2.
Can I write that N2 and calcium 3 or no?
Oh no, not at all. No.
The
Yeah.
one with the larger.
No, the metal element always goes first.
Okay, the metal. Okay.
Yeah. All right. So when we talk about ionic compound, we always write a symbol of the metal element followed by a non-metal element.
Okay.
Do you understand?
Yes. Yes.
Everybody, do you understand this? Right.
Yes,
Again,
Professor.
bucket method is only for your explanation, just to be visualize this. But in actual course, you can just cross multiply and that works.
Well, the bucket actually helps students understand.
Yeah.
So I think it's a good method.
Yeah, I prefer
Yeah.
the bucket too.
Yeah, but like when you're saving time, cross multiplication works. But this is something which is going to help you to visualize that why is this,
Yeah, to help
right?
you understand.
Yeah. All right.
Yeah. Thank you.
Okay, no problem. Anybody has any
Thank you.
question before we move on? What time it is? Oh, we have 15 minutes. Okay. Any other questions? Okay.
No?
Okay, great. So now I think because of the 15-minute time, I think I cannot cover this at all, right? I cannot continue with this because you guys definitely need more time to understand this. So what I'm going to do, I'm just simply going to look at the handout that I share with you. I'm going to give you like 3 minutes, like not 3 minutes, maybe like 1 minute to open your handout and look at the page number 2. All right, I'm going to go over with the information that I gave you already, just to make sure that you understand what information you have on your hand. Okay, so everybody please, either if you have printed out or if it's a soft copy, please open the handout that I sent to you. And let's look at the page number 2 where it says, sorry?
It's not numbered.
Okay, so sorry, my bad. It should be page number 3. We are talking about how to write name of ionic compounds from the given chemical formula.
See
How
it.
to write name of the ionic compound. Ionic compound from given chemical formula. Right? How to use that information. For cation, I already told you what information you have to use, right? So you can just remember that for cation, right, you are always going to write it as an element. All right, if the element is from transition element section of it, in addition to the name of it, you are going to write a parenthesis and write a Roman numeral. Okay, for Roman numeral, right, there is 3 exception. So keep this table handy, like keep this paper handy with you. Which are the 3 exception? Silver, which is Ag, cadmium, Cd, and zinc, Zn. These elements are present in a transition element category, but still they do not carry more than 1 charge. It means Ag is always going to carry +1 charge. Cadmium, I think always +2. I don't remember. Cadmium should be +2. Yeah, I just check, like you can check this out later, or I might correct myself later on, right? But cadmium I think is +2 and zinc is always +2. So these are the 3 exceptions that even though they are in a transition element, they do not carry any other charge than this. That's why when you name this compound that has this element, you are just going to name it as an element. You are not going to write any Roman numeral. Why? Because it does not carry any other charge than this, right? Same like a Na and magnesium. as you know, it is always going to carry +1 charge and +2 charge. These three transition element are always going to carry +1 charge, +2 charge, +2 charge, right? So for this element, we do not need to write a parenthesis. Do you follow?
Yes, Professor.
Yeah.
All right. So please, of course, there is some memorization, but with practice, you will definitely understand this. Okay. So keep this handout handy. I have given you all the information that you need for naming this compound. All right. It's going to be very, very helpful once your lecture professor go over this. All right. For anion, we did talk about monoatomic anion, right? When there is only one element is present as an anion, that is called monoatomic. And to name that anion, you are always going to use suffix, which is IDE. All right. But we haven't been able to touch the polyatomic anion. So I'm briefly going to talk about that. Remember, it is having many different rules. All right. So to make sure you understand this, stay focused. All right, in terms of polyatomic anion, all right, the first thing is that there is only three exception in which we are still using IDE as a suffix, even though this has more than one element in them, right? All right, so these are the three anion: OH minus ion, CN minus ion, and O2 minus 2. All right, what do we call this? We call this hydroxide. Why? Because it's hydrogen and oxygen. Hydroxide. We have hydrogen and oxygen. The name of this anion is called hydroxide. The name of this anion, Cn minus, is cyanide. All right, and the name of this anion. So if I'm going to ask you this, O minus 2, what you going to call this anion? Anybody?
Dioxide?
Mm,
Just like oxide?
just oxide. That's right? If you remember, we do not use di-tetra if we are talking about iron. Remember that, okay? If you're talking about iron, we do not use di-tetra. The second thing is, if it's just oxygen itself, right, which is considered as monoatomic anion, then yes, we are going to call it as an oxide. In this example, right, this is something we're going to learn, and this is kind of a bit off track. So there is something, a memorization that you need to do. In this case, whenever we have something extra, in this case, we have one extra oxygen, what we're going to call this? Per, like hyper, right? Hypo and hyper. So instead of using high, we're just going to call peroxide. So the name of this ion is called oxide, which we learned earlier, right? But if you have O2 minus 2, then we call it peroxide, like peroxide. Okay, why? Because we have one extra oxygen. Okay, do you understand this?
So hydrogen peroxide would be like the same thing, just with the H.
Yeah, this is
H2O.
called
Figura
hydrogen
H2O.
peroxide.
Yeah.
This is called hydrogen peroxide. Right, what we learning right now is only anion, right? So that's why we are focusing on oxygen.
Peroxide. Because it has two
Okay.
molecules of oxygen.
Yes. All right, and as I told you, this is an ionic compound, right? In this, okay, this is hard to explain you that. Yeah, it's going to be tough. Okay, but as I told you, just remember this as an exception. All right, yes, this is not exactly like ionic compound, but it is actually ionic compound. So let's just keep this as an exception. All right, but yes, the chemical formula for hydrogen peroxide is H2O2, and this is the name, hydrogen peroxide. All right, in second, where we have that, in polyatomic anion, the second category, the second suffix we're going to use is ATE. All right, the first suffix we can use is IDE. This suffix only apply to these three polyatomic anion: hydroxide, cyanide, and peroxide. We still see this. This is going to end with IDE, IDE, and IDE. Okay. Now, which are the one which is going to end with ATE? So I hope you guys seeing a table right now, right? At the bottom of the paper, like bottom of the page number 3, you see a table, right? Which says CO3 minus 2, NO3 minus PO4 minus 3, SO4 minus 2, and ClO4 minus. All right. All of this ion that you see, it is polyatomic anion because you see more than one element as an anion, right? All of this ion, when you're going to name it, you're going to name it as a ATE. You already see the name in that table. This is called carbonate. This is called nitrate. This is called phosphate. This is called sulfate. And this is called perchlorate. All right. Again, we use perchlorate in this example instead of just chlorate. There is the reason behind that. All right. Which I'm going to kind of, when I'm going to share more detailed handout on naming this compound, I'm going to share that with you. All right. But do you follow? Do you understand this? Right. I know it's so much
Yes.
information. Sorry.
Confused.
Confused. I know.
I think it's just a lot of information. We had to just go back and slowly check it again.
I know. I'm trying
But
to
if
go
pero we're
as slow
thankful
as
for
I
that,
can.
Professor.
Yeah, I'm trying to go as slow as I can. But let me just explain you one more time.
No,
All
it's
right?
okay. It's all
This
good.
will be
Thank you.
Yeah, this will be the last point that we're gonna discuss, and then I'm gonna let you go. Okay. Thank you so much for your patience. And remember, this is not hard. You are just kind of coming across this thing first time. That's the only thing. All right. So again, this is just a part of the periodic table. All right, in which we have carbon, then we have nitrogen, we have oxygen, right? I'm not going to write. Okay, let me just write oxygen. We have phosphorus, we have sulfur, and we have chlorine, right? This is how the periodic table look like. We don't have any anion with this oxygen here, so I'm not going to write that, but this is just a part of the periodic table. Now, if you have to come up with this periodic table, or if you have to remember when you're going to use ATE as suffix, all you have to do, just put oxygen with all of this element: oxygen, 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 oxygen. Okay. Now what we're going to do, we're just going to find out how many oxygen. So if you look at this, this is period number 3, period number 2, sorry, my bad, and this is period 3, right? I mean, this is the second row of your periodic table. This is going to be the third row of the periodic table. If it's a second row, what you're going to do, you're going to add +1, which is going to be equal to 3. So that number is going to be the oxygen. So it should be 3 and 3. Okay. For period number 3, we're going to put 4 oxygen: 4, 4, and 4. Okay. First of all, we're just going to put oxygen with each of this element. Second, how many oxygen are we going to put? We're just going to add one number to the period, right? And we're just going to add that. So if it's period number 2, we're just going to add one more, and it will be 3 and 3. In this case, 4, 4, and 4. All right. Now we're just going to find out what should be the charge. So for the charge, we just can remember -1, -2, -3. Again, we're going to start with that: -1 and -2. If you remember the steps, then you come up with the table on your own, right? In which all of this anion is going to be end with ATE, right? As we just discussed: carbonate, nitrate, phosphate, sulfate, and chlorate. All right. Now, in the second example, and this is the last point I'm going to discuss at this moment, in some polyatomic anion, we have to use ITE as suffix. And which are they? This is for ATE. There is one for ITE. For ITE, all you have to do is you have to have one less oxygen than the one that you have in this table. All right. If you have NO2 minus, then it is called nitrite. If you have PO3, one less oxygen, same charge, okay, this is going to be called phosphite. If you have sulfur with one like SO3, one less oxygen but the same charge, we call it sulfite. All right, so this is something you can remember at this moment. All right, everything that you have in this table that is going to end with ATE. If you have one less oxygen than what you have in the above table, then you have to write your name as ITE, like nitrite, sulfide, and phosphite. All right, do you follow this?
Yes.
Yes, yes, Professor.
Yeah, I know there is a memorization. That's why I was trying to focus more on this. But like you guys had like a good number of questions, which I did not feel like skipping them. So we kind of run a little bit behind than my actual expectation. But that is completely fine. It is more important that what we learn than how much we learn. All right, I don't know why. Okay, just give me 1 minute. There's something wrong with my computer again. Right, switching. Yes. Okay. All right. So, okay, what did I do? Yes. So, yeah, there is some information that you need to remember. Of course, all the material that you need for naming this compound correctly is given to you. All right. So, do not worry about this. Whatever you study right now, it is all advanced study, right? You haven't even started your course yet. So you are very ahead of everyone else who is not kind of, taking this kind of workshop. All right. So trust yourself. You are going in the right direction. If you need help during the during the semester, okay, do you want to? Yeah.